The first quarter of 1957 was marked by an intensification of test activity over the network of Atlas facilities. At the Air Force Missile Test Center, site expansion continued, while preparations were made for first flights. Edwards Rocket Base increased its test activity and facility buildup. In the San Diego area, Sycamore Canyon also expanded, and the program was advanced with scheduled missile firing. Construction work was progressing on a new astronautics center, and Point Loma continued work on the proofing of advanced missile components. At the Systems Integration Center, strides were made in production through the efforts of associated Atlas contractors. Prime contractors to the program are responsible for development of engines, design and production of the nose cone, guidance system, first operations base at Camp Cook, California, propellant transfer studies, guidance computers, and accessory power supply. On February 5th, 6th, and 7th, Western Development Division of ARDC and associate contractors made a group presentation to Air Force representatives at the Convair plant in San Diego.
Gentlemen, I'd like to welcome you here at Convair. We are duly impressed by the project which you have set up for the next few days and by the tremendous attendance here this morning. These very bright lights which you have beaming down on you will not be on too long, they tell me. The object of having them is to take some motion pictures which we have been requested to do so that they may be included in the WDD report and in our quarterly progress report on the Atlas project. I hope the qualitative aspect of our work...
Purpose, presentation of plans for development of missile ground support equipment, with emphasis upon the initial operational capability of the weapon system. Pertinent items of support equipment were shown and demonstrated for those attending the conference. On display were items of missile hardware with Allied ground support equipment, ground handling and test equipment, much of it representative of IOC equipment, and test sets such as these. Reading from left to right, they are the semiconductor power diode and rectifier, propellant utilization and transverter test sets, cable and impedance test sets, and transducer power supply, harness test sets, and programmer test set. Associate contractor items included this pulse generator, guidance control mock-ups, the encoder programmer, and improved guidance canisters. Models of IOC equipment were displayed, such as this: the operational nose cone with its handling container, and mock-ups of operational control consoles. Highlight was the presentation of the first operational base to be built at Camp Cook, showing the squadron maintenance area, guidance center, launch control center, and the launching site, including the environmental shelter. Larger items of ground support equipment were demonstrated at an adjacent outdoor area. On exhibit were portable work platforms, mobile electronic maintenance trailers, a 60-cycle emergency diesel generator, a 400-cycle AC missile ground power motor generator, booster handling sling, liquid nitrogen trailer, missile handling trailer, standards maintenance trailer, helium compressor, booster handling trailer, and canister handling cart. To conclude the conference, representatives of different Air Force elements presented their critique of plans presented. Progress on weapon system WS-107A to the present has been concerned with production and testing of A-series missiles. This item is a test vehicle, the initial step in a comprehensive program of evaluation, utilizing the first stage propulsion system for proving out basic concepts. Technicians prepare for the evaluation task with the installation of transducers. The link between test missiles and ground stations is the transducer and telemetering system. Transducer installation is one of the final steps in assembly. These tiny instruments are placed at critical points about the missile and provide the signals which will be the only record of performance after flight articles are gone. During static or flight tests, transducers convert physical forces into electrical energy, transmitting information to the airborne telemetering system. Telemetering channels transmit modulated signals to ground station receivers. During flight tests, this will be accomplished by means of high-frequency radio waves. During checkouts and static firings, transmission is through landlines. In the plant, telemetered signals are picked up and recorded by the electronic test laboratory, which duplicates the standard telemetering ground station. Receiving equipment here is capable of simultaneously demodulating missile subcarrier signals. These are recorded on multiple-channel magnetic tape. Visual observation is provided by oscilloscopes. Test information may also be monitored by oscillograph and photooscillograph recorders. After a test, the recorded tape is removed to the central instrumentation checkout station for duplication and data reduction. Engineers at the ICS station for data reduction evaluate results from each test site. First step is playback of the test record. Signals from the 14-channel magnetic tapes are fed to continuous data translators and commutated data translators. Discriminators convert frequency deviations into required patterns for translation into readable forms. Accurate analysis of telemetered information is of great importance in raising the confidence level of the test program. Evaluation is based on digital printouts, oscillographs, and photooscillograph records. Since there will be no way of retrieving missiles following launchings, engineers will rely on telemetered information to evaluate flight performance. It will be possible to reconstruct every phase of flight by means of this equipment. In another plant area, General Electric engineers check out airborne guidance equipment scheduled for installation on production missiles. Laboratory personnel and equipment prove out the units as a system in preparation for integration into the missile electronic system. Representatives of the General Electric nose cone group are located in another plant area. Another group represented at the San Diego plant is American Machine and Foundry. In an area adjacent to final assembly, representatives of Rocketdyne serve as a link between the engine contractor and systems integrator. Resident engineers receive, inspect, and check out engines upon arrival. One function of this group is to provide assistance in proofing advanced designs, such as that required when the sustainer engine is added to the missile configuration. Here, work is progressing on the metal proofing mock-up of the B-series missile. The mock-up provides an exact full-scale model for accurate spacing of the components required by the addition of the sustainer engine. B-series equipment pods are arranged to include all telemetering canisters on one side, flight control items on the other. Here, technicians are fitting full-scale General Electric airborne guidance components into the target side pods. Production techniques are developed as a result of work done here. On March 24th, Missile 1B was in the major assembly jig, as shown in this shot during off-production hours. 2B, 3B, and 4B were in various stages of fabrication. In the final assembly area, Missile 6A was under security wrap, ready for shipment to Cape Canaveral. In final checkout were Missiles 8A, a flight test spare, and 9A, to be the second bird tested at Sycamore Stand 1. Motion pictures were taken during off hours to avoid causing production delays. In the first row of final assembly docks, reading from left to right, were Missiles 13A, the third missile to be flight tested at Pad 12. 10A, second flight article for Pad 14. And 12A, the second flight article for Pad 12. The second row of final assembly docks contained, from left to right, missiles 15A, the fourth flight missile for Pad 14, 14A, designated as the second test bird for Edwards Rocket Base Stand 1A, and 7A, scheduled as the third missile to be launched from AFMTC Pad 14. Missile 11A, a flight spare, is stored in another building at the San Diego plant. On March 28th, Missile 6A was moved from the San Diego plant for delivery to AFMTC. Missile 6A is a flight article, the first assigned for launching from Pad 12 at Cape Canaveral. The launching of this missile will follow that of 4A by about 2 months. Other sites of Atlas activity in the San Diego area, Sycamore Canyon, the new astronautics plant, and the Point Loma extension of the main test lab. An additional facility, located on San Diego Bay near the plant, was used during the quarter for special studies. During January and early February, a series of interim sub-tank pressurization tests were run. Objective: to accumulate data on the amount of helium required to pressurize the tank during flight. Liquid nitrogen was used to simulate LOX, and the test was run under varying conditions of applied heat and pressure at known flow rates. Heat input ranged to above 20,000 BTUs per square foot per hour, and was found to have less effect than was anticipated. Gas samples taken during the test provided data for the evaluation, which indicated a margin of safety over that calculated. The principal extension of the contractor's test lab is located at Point Loma in the San Diego area. Test stands here are used in conducting research involving some degree of hazard. The installation shown here has been set up for checkout of the accessory power supply. This unit, developed by American Machine and Foundry, is an airborne high-speed turbine which provides hydraulic power to engine actuators and electrical power to missile accessories. During the quarter, first runs of the APS at the Point Loma site were made and served to familiarize personnel with the unit and its support equipment. A rich mixture of fuel was used in this test to prevent overheating of the unit. An afterburner was attached to eliminate residual vapor from this mixture and added safety precautions. 37 runs were made, with progressive time trials ranging from 30 seconds to 6 minutes. The launcher mechanism at this site was subjected to a series of tests during the quarter. Here you see a simulated missile launching, with thrust and acceleration provided by hydraulic rams. Response of the mechanism was good under all test conditions. Evaluation will provide significant data for the flight test program. Expansion of the Point Loma facility is keeping pace with the needs of the Atlas project. Recent additions to the area include the staging stand, upper left, where jettisoning of the thrust structure will be simulated, an administration building, far left, and an extension to the blockhouse. Progress is toward greater capability in the proofing of advanced missile components. By early 1958, astronautics projects will have completed the move into a new facility north of San Diego. A model of the new plant shows the 6-story engineering building, reception center, 6-story administration building, engineering laboratories, computer building, and manufacturing building. This is the construction status of the engineering and administration building at the end of the quarter. The first 3 floors of the 6-story buildings were in place, and work was underway on the reception building. The reception center is scheduled for completion in June, the 6-story buildings in September. Engineering laboratories are 1-story buildings of waffle-type construction. These buildings are scheduled for occupancy in July. This is the engineering computer building. Part of the engineering laboratories, completion is expected in July. In January, construction was begun on the manufacturing building. The 500,000 square foot building will be in full use by early 1958. A short distance north of the new facility is Sycamore Canyon. A plan view shows the relative position of administration building, assembly building, S1 and S2. This site offers the advantage of being close to the manufacturing and integration center. Test stands at Sycamore serve as static firing bases for exploration of the compatibility of missile airframe and integrated systems. At Stand 1, 2 full thrust firings were accomplished during the quarter, making a total of 4 tests run at this site. The missile is 3A, the run number 103-1. The date, February 18th. Objective, a 5-second firing to obtain information on engine and airframe compatibility. Test the ability of the autopilot system to hold engines null during firing, and check the functioning of the pressurization system under sustained flow conditions. With the successful conclusion of the firing, a subsequent run was scheduled for progressive evaluation of additional components. Sycamore Canyon, March 21st. Test objective, a 15-second hot run to verify the structural integrity of the missile when subjected to limited thrust chamber gimbaling and increased propellant loading. To test telemetering and range safety command systems during the firing, and to test the airborne pneumatic system for the first time. All primary test objectives were accomplished. Next run is scheduled for early April. The second test stand at Sycamore, designated S2, is under construction. Here, the first B-series missile static tests will be conducted. The stand had reached this stage of completion at the end of the quarter. Erection of the service tower was to start April 1st and be ready for use in July. The blockhouse has been finished, ready for installation of electrical and electronic equipment. B-series tests are scheduled to start early this fall. Edwards Rocket Base Air Force Rocket Test Laboratory in the Mojave Desert of California was the setting for additional Atlas testing. Facilities provided at this site include the Missile Assembly Building, Test Stand 1A, Stand 1-1, Stand 1-4, and a research test site not shown. Stand 1-1 was near completion at the end of the quarter. On March 7th, engineers checked out the missile water deluge system. Fog fire protection blankets all missile surfaces at the rate of 3/4 gallon per minute per square foot of surface. A spray head sprinkler system protects all platforms not covered by the fog fire system. On March 20th, A-Series missile number 5 was taken from the assembly building to the test stand. This missile was delivered to the Air Force site early in the quarter. Transport to Stand 1-1 followed full checkout of missile components and systems in the assembly building. Firing tests will begin during the second quarter. This is Stand 1-4, first to be used for combined engine, thrust structure, and systems testing. At 1-4, fuel and locks are fed from a heavy-walled battleship tank for safety during progressive evaluation. Major changes here during the quarter have included engine and thrust section replacement, installation of the lightweight airborne pressurization system, and addition of vernier engines and deflectors. There were 10 test operations during the quarter, for a total run time of 380 seconds. During this 3 months, information was obtained on autopilot control of boosters in pitch and yaw, performance of the pressurization system, operation of hydraulic engine actuators, ability of the airborne pressurization system to perform satisfactorily, heat exchanger characteristics, and for the first time here, performance of vernier engines during 3 short static firings. The final run of the quarter was made on March 14th. Objective, a 65-second firing to determine if the propulsion system would operate satisfactorily, the LOX head suppression valve locked open, and with varying pressure at the LOX pump inlets to simulate flight acceleration forces. A secondary objective was to test Convair-supplied transducers and the frequency response of the autopilot system in pitch. Modification of Stand 1-4 to accommodate B-Series components will be accomplished during the second quarter. At Stand 1A, preparations were underway for tests on A-Series missile number 2. Telemetering and systems checkout trailers were moved to the site, where a greater degree of integration of operational equipment will be attained. LOX storage facilities, completed and proved satisfactory, were ready. Liquid oxygen is now being manufactured at the base LOX plant. Preparations at Stand 1A included personnel familiarization with equipment and training in countdown techniques. Contractor technicians made several dry runs of the countdown, working with associate contractor engineers. General Electric guidance system control and monitoring equipment was integrated into the countdown procedure. United States Air Force technicians participated in the operation, being responsible for data recording. First test here was run on March 25th. This was a LOX blowdown to check out the missile propellant system and support equipment. Initial checkout was satisfactory, and Missile 2A was scheduled for a short main stage firing in early April. While engineers were conducting research at the California site, preparations were underway to start the flight test program at AFMTC. Atlas installations here include assembly buildings J and K and flight complexes 11, 12, 13, and 14. At the flight area, work was continued on the launching pad. Pad 11 was on schedule, and by the end of March, ready for service tower and flame deflector installation. Pad 12, next in line, was completed except for some painting and ready to receive Missile 6A. Pad 13, third pad north, will be the last finished. Construction is about 1 month behind that at Pad 11. Pad 14, furthest north, will be the site of the first flight test. The flight complex is the hub of the Atlas test program. Here, for the first time, the many intricate items of control, maintenance, support, and evaluation are brought together as a single system in preparation for actual launching. Control center is the blockhouse. Tasks accomplished here during the quarter included the completion of equipment installation, calibration of all instruments, checkout of all support items, training of personnel, and detailed rehearsals of each phase of the flight operation. Missile checkout prior to flight is accomplished in the assembly area. Building J in the foreground was completed last year. Building K will undergo construction modifications this summer. Building J is in use as a missile work area and administration center. Here, technicians performed modification and checkout on Missile 4A during the quarter. The task included installation of the modified canister straps, continued work on shortage items, and engine modifications by Rocketdyne technicians. Missile 4A was removed from the assembly building on March 21st. Destination, Pad 14. This was the ramp and test stand at Pad 14 on March 21st. Missile 4A, first flight article, arrived to begin the countdown of activity leading to first flight. The raising of 4A in the service tower at the flight complex follows the pattern established in handling other test vehicles at Point Loma, Sycamore Canyon, and Edwards Rocket Base. The checkout and interrogation of components and systems will proceed along lines established by test engineers at the other sites. Each separate piece of hardware and every electronic and mechanical component has been subjected to intensive evaluation, from the hold-down mechanism to the smallest transistor. 4A differs from other test missiles in that it is the first of a series of flight test articles, a progressive step in the overall program. initial run at Launch Complex 14 will be a short static firing. Then, first flight, scheduled for the second quarter, 1957.